So we're going to tackle some weird that's going to come back in chapter 4, but we'll be doing this with limits. It'll be very similar, so getting practice now will pay off later, because it does return. And you should put at least one of these on the file. We want to find the derivative of y with respect to x, where y is equal to x to the x. Now, we can tackle y is equal to x to the power of n for n being some number, some real number, anywhere from negative infinity up to infinity. Not included in the endpoints, of course, because those don't exist. But right, but the problem is that's a number. So that one won't work. We got y is equal to b to the x. Remember that one? There's some exponents, but shit. B's got to be positive, and it can't equal 1, so we must be talking about b's just a number 2. So neither one of these is going to work. Y is equal to x to the x is not going to work. We're going to have to do something with this. And now, a wise man told me years ago, hey, you need to get a variable out of an exponent. Just hit it with a log, dude. That's all you got to do. Just hit it with a log. Very wise man. So both sides of the equation, we're just going to hit it with a log. So ln of y is equal to ln of x to the x. Well, what have we learned? What have we learned? What's so great about ln's and these powers? That x is falling down. So we get ln of y is equal to x times ln of x. Bro, what's up? What's up, dude? F and a G, maybe? Just do a little quick product over on the side. Handle that natural log of y, taking that derivative. That's not so bad. So let's take that derivative on ln of y on the left side. So 1 over y. And then since we're taking a derivative on anything with y, it's a chain. And we have to multiply by the dy dx, what we're looking for in this problem. So we're going to need to multiply that y back on over when we get done. So, there's that product. So we'll just do x and ln of x, your f and your g, write its derivative right underneath it, 1, ln of x, 1 over x. Make yourself a little x, and we're off and running. So it's that 1 times ln of x, so that's just ln of x, plus x times 1 over x, that's just 1, right? They cancel out. Cool. So let's multiply over the y, and you get y times ln of x plus 1. You're going to get sick and tired of writing that y. I would have just wrote it in directly there as x to the x, but we're showing these steps. There'd be your solution. There it is. Cool. That's a classic. Straight up classic. That's like when I was a student, that was like the question at the math center. They would ask you if you wanted to be a tutor. One of many. But I knew this one when I applied. And I actually didn't get the job. I'm a teacher now. It's good. All right. Y is equal to x to the power of cosine of x. Again, we got a function raised to a function. So we need to get that thing out of there. And just to state it right now, don't you dare subtract 1 from variables and functions. Don't you dare. I see that. That's like immediate, like I'm just stealing all of your points. Don't do that. Don't subtract 1 from variables. Subtract 1 from numbers. Don't subtract 1 from functions. Subtract them from numbers. So don't use power rule and stuff like this. So we're going to hit it with a log. And we'll rewrite it. ln of y is equal to ln of x to the cosine of x. But that thing is just going to fall to the front, and it's the same frickin' problem. It's just a little bit different of a product rule. This is mellow. This isn't that big of a deal. We get our 1 over y dy dx. I'm not going to show this step this time. So I'm going to leave cosine of x alone and multiply by the derivative of ln of x. That's 1 over x. Next, I'm going to go through and we're going to add to it. We're going to take ln of x. We're going to multiply it by the derivative of cosine, which is negative sine of x. Now we multiply that y over to the other side. We're not going to write it. There's no way, no how we're not going to write it as y. We'll write it as x to the cosine of x times cosine of x over x. minus the natural log of x times sine of x. And there is our solution. So it's the same game, kind of the same way. There's more to it, but this is just a product. It's just an f and a g when you go through and do this. All right, now these can get pretty tricky just from exponent rules, log rules, combining them. Like this next problem will show you, it's like if you got your shit down, it's not terrible. But I know, like I look at this, you asked me to find the derivative of that. Is it Calc 1 student? No way. Just no way. I didn't have the algebra knowledge. I don't think I had that in Calc 2 or even Calc 3 yet, to where I actually could really break down what the heck is happening. And it's crazy looking back now, like it's so simple, yet there's so many rules in algebra. There's so many. So let's go step by step and do some algebra before we go into this. So we've been learning we don't like that, we don't like the square root of x. So let's just write that in as x to the 1/2 power. And I'll do x squared cubed. Isn't that just 2 times 3 is the exponent, so it's x to the 6th. So this is just a half of x, where it's the exponent. So we can say it's y is equal to x to the half of x. Well shit, that's just like the other problems we did. Except this one's going to be simpler. It's just a half an x. Well, I don't know about simpler. We did x to the x. Now we're doing x to the half an x. It's just a constant. It's no big deal, but it's just the moral of this is little things like that root, and how do we put it together with that x? I think you have one in yours, and it might be the opposite way. It actually doesn't make any difference whether the x is inside or the x is on the outside. But, yeah, what's going on? Let's take that derivative. So we end up with, oh, no, derivative. We can't hit it with the derivative. Yeah, I'm jumping the gun. That's a function to a function. We got to hit it with a natural log on both sides. And I'm going to cheat this time and just write it in. 1/2 x times ln of x. Put a little parenthesis around it. Maybe we do one of these so you can see there's f, there's g. Now we take a derivative on ln of y. That's going to become 1 over y dy dx. And now we go do our product. So let's take a derivative on 1/2 x, and then we'll leave ln of x alone. Now we'll add it to, let's leave 1/2 x the way it is, and then we'll multiply by the derivative of ln of x, that's just 1 over x. Oh, shit, look at that. Cleaning up, looking so freaking similar. So similar to the problem we did before, just with a little bit of a different number. 1/2 ln of x plus 1/2. Now we multiply that thing on over, and we have that. However you want to write it, I'm going to write it as the original. The square root of x to the x times 1/2 ln of x plus 1. Oh, look at that. I have a factor to it there. It's being a dick. It's just, that's preference. You could have just left this too. There's the problems. I don't know, they're not that bad if you know your log rules. If you know your exponent rules. They're not terrible, but they just something to be mindful of, something to work on, something to get better today with. I'm going to have one more that's just a random video, and then we'll be on to the next.